Hi everyone. So this is the part two of the week 5 video. So hopefully if you're watching this, you've already watched Tara. Tara's video covered conditional statements using the tidyverse. Conditional statements are if else, if then, else if statements. So if the value is this, do this thing. If the value is that or some other category, do this other thing. If you haven't watched that, please go ahead and watch that and then come back to this video. We're going to cover two things in this video. So the first thing are joining operations. So sometimes in R, some joining uses the term merging instead. We're going to use join because that's what the tidyverse uses. Joining is about bringing data frames together. So you have data frame A, data frame B, and you want to somehow combine them or match them against each other. And so we're going to talk about a series of operations for doing that. Second part of the video, we are going to talk about pivoting. So pivoting is I have a long data frame, I want to make it wide, so going from lots of rows to lots of columns, or I have lots of columns and I want to make it long, so going from lots of columns to lots of rows. If that doesn't make sense right now, that's okay. We're just starting the video. We're going to get to the rest of it. As a reminder, all of the material we go over in the videos is based on the tutorials page on the course GitHub page. So if you go to tutorials and there's a little drop down, today Tara's video and then the videos I'm presenting are all from data manipulation part 2. And so if you're lost, that's where we are going. And in fact, let me go ahead. I'm going to share my screen briefly. So hopefully you are seeing the joining two data frames page on the course GitHub site. So now having established that, I'm going to change again. Oh no. I'm going to stop sharing. There we go. Okay. So now I've pulled up my RDavis window. I'm working in my RDavis in-class project, my RDavis window, the RStudio window. So hopefully this looks something like yours. I have a blank spreadsheet open, a .r file. So I'm going to go ahead and save it. In this case, I'm going to call it week 5 joins pivots. So joins underscore pivots.r, and I'm going to save this file in my RDavis project subdirectory called scripts. And so you can find this if you go to our GitHub page and you pull up my repo. After this video is done, I will save, commit, push, and then merge this into my main branch, and you will be able to follow along. So I had R open earlier, so I'm going to restart R quickly so that everything vanishes and no packages are loaded. First thing I'm going to do is I'm going to load the tidyverse, library tidyverse. Typo there. You get a bunch of messages, but in the end, the tidyverse loaded. First thing I'm going to do is I'm going to use the read underscore CSV function to read in a file that you can find in the data subdirectory of your class repo, tail underscore length.csv. I'm going to name that file tail, read that in, and sure enough, if we look at this file, I'll use the head function to look at the tail file. We have a tibble, and it has two columns, record ID and tail length. It has, we call the dim function, 34,786 rows and two columns. So if yours doesn't, let us know. That would be somewhat unexpected. You should have the same file as we do. So we're working off the same thing. Okay, so you probably guessed, since we have tail length and record ID, that what we're going to be working on is actually merging tail length back into the core data frame that we've been working with. And that, sure enough, is the case. Before that, I want to highlight the 4 sort of different approaches to joining data frames in the tidyverse. They all use the same basic format. So I'm going to type some pseudocode. Pseudocode is code that doesn't actually run, but it's sort of written. It's like code-ish language to show you what I'm talking about. So every join function in the tidyverse is something like join function, and then it's data frame A, data frame B, and then how to join. And that's fundamentally what all of the four join functions do. So I'll show you what I mean by that. The first function is we're going to present. Make sure I'm lined up with it. I want to present it in the order we do in the tutorial, is inner join. So what inner join does is it takes X and Y, or A and B, and it says we want to merge only on the common column. So what that means is if the ID value is in data frame A, and in data frame B, it will match, merge, and then get rid of any record IDs that are not in both A and B. So I don't remember the logical term for this, but it's like the inner set. So an inner join creates the inner set where there's a match in both. So that would be data frame A. You don't always have to type common ID. So to show you what I mean here, let's go ahead and read in the surveys data frame like we have before, read_.csv, data/portal data joined. So if I call inner join, I'm going to say X is surveys and Y is tail. And if I run this value, it just works. And the reason it just works is RStudio has a default where if you do not tell it what columns to join on, it looks in X and it looks in Y and it says, I'm going to join on every column I see that has the same name. And so in this case, there's only one common name, record ID. And so it joins by record ID and it kind of just works. But that function is the same as if we say by equals record ID. One thing I want to highlight here, in this case, you have to give the string name. So we've had that sort of confusion. There's not necessarily a hard and fast rule. You just kind of have to store away a little bit that in your head that there are some cases where you call out the column name as just a name, some cases as a string ID, and know that like if you are trying to write some code and you do it one way and it doesn't work, try the other because that might be the simple reason why it's not working. So I want to highlight, I'm going to call dim on the inner join function. So I'm not going to save this object yet. I'm just going to call dimensions on it. And in this case, we actually end up with the same set of dimensions because every observation in tail and in surveys is matched in the other. There's 34,786 in both. All the record IDs are in both places. Make another comment here so you can reference this. Inner join only keeps records that are in both data frames. Okay. Next version is called left join. So we're going to learn about left join and right join. They're actually the same thing. It's a convenience function. I'm going to show you why that is. So left join takes data frame X and data frame Y, and it looks for any value, any ID in Y that exists in X, and it takes those values of Y and appends it to X. So it's slightly different than the inner join, which only keeps records that are in both. Left join keeps everything that is in the left-hand side and only matches in the right-hand side. So right join is the opposite. Everything that's in the right-hand side and only matches that are in the left-hand side. That's why right join and left join are actually the same, is you can either use the right and left join functions, or you can just move which is X and which is Y. So let me show you what I mean by that. Left join takes data frame X and data frame Y, and it keeps everything in X and only matches in Y. And right join does the opposite. Right join takes data frame X and data frame Y. So we can do left join X, Y, and that actually equals right join Y, X. Conversely, too much copy and pasting there. Right join X, Y equals left join YX. So for me, I find it easiest to think in terms of what the function actually does. And so I just don't use right join ever. If I need to join and I want to keep everything from one data frame and only the matches in another, I only use left join and then I shift which one is X and Y. And I find that intuitive because I like to think about the first one being the thing I want to keep everything from, and the second data frame being like the one I'm looking for matches in. And so for me, it's most intuitive to just use left join, have X be the thing I don't want to alter, and Y be the thing I want to only grab the matches from. But I'll show you we can get the same result with both. So in this case, left join. And what we want to do here is we want to join tails back into surveys. So X equals surveys and Y equals tail. And then let's just specify record ID to be very clear about what we're doing. I'm going to call dim on this. Actually, I'll save it as an object first. So call surveys left joined. And now I'm going to copy this. I'm going to make surveys right joined. And let's go ahead and manipulate which is the X and which is the Y. And we don't actually have to alter the order here because we're specifying the function name. So if we don't specify the function names, the inputs, if you just type surveys and tail, R assumes the first one is X and the second one is Y. But in this case, we've said, no, Y is surveys and X is tail. So we've reversed the join. And if we run both of those, because I already proved to you that all the record IDs are in both, they're going to be the same here because we're keeping everything. And sure, didn't finish the object name. And sure enough, we again have 34,786 and 14 rows and 14 columns. This also would have been the same if we didn't have all the record IDs in each, because we were doing the same join in terms of keeping everything in surveys and only the matches in tail. So inner join, left join, and right join. The final case is full join. And full join keeps everything. And I'm putting that in all caps because it can get crazy if you don't have a common ID. So when you call full join on record IDs in surveys and tail, there is a record ID in there. And so R matches 1-to-1. But if you don't, then R says, all right, well, you said keep everything. And I don't know what to match on. So I'm not quite sure what's going to happen. You can get a weird error message. The other time you can get a weird error message with this is if you call full join and it doesn't have a unique identifier. And so what I mean by that is there's like one to many or many to many observations in the X and Y data frames. And then R tries to match all of those and it can explode very quickly. You get like a matrix expansion. And so sometimes if you call full join on data frames that don't have common identifiers, but do have common values, that many to many join will result in like the world's largest matrix, and R will give you a threatening message if it works at all. In any case, so let's try full join. Full join, X equals surveys, Y equals tail. And just to prove it, we don't have to specify record ID. It's just going to work. If you scroll up, R says joining by record ID. Sure enough. And surveys full join is what we'll call that object. And it has 34,786 rows and 14 columns. So this was sort of an easy case. And I say easy case because there was a common record ID and this one just kind of works by default. That's not always true with real world messy data. And so the behavior to be aware of is what R does if it matches on something, but there's not matches on another, is it fills in that join with NAs. And so, for instance, if there were record IDs in surveys that were not in tail, then, but there were some record IDs in both tail and surveys, R is going to merge tail back into surveys. The tidyverse function is going to merge, I should say, and it's going to create a tail length column. And then any case where there was no record ID in that tail data frame, it's going to put an NA for tail length. And so you create NAs where you don't have a merged value, and then you get the merged value where there was a common record identifier. That doesn't really crop up here, right? Because we have sort of clean data with the same record IDs in both, but that's how R handles the case where there are some common identifiers that match and some that don't, is it expands and then creates NAs where it doesn't have the common value. So go ahead and take on the challenge yourself at the end of that, and we will talk about it in class. Okay, so now we are pivoting to pivots, pun intended. So pivoting is also sometimes called reshaping, and functionally we're going from long to wide or wide to long. We are trying to preserve the core idea that every variable has its own column, every observation has its own row, every value has its own cell, and each type of observational unit forms a table. And so that all sounds like a bunch of jargon, but the reason we state those rules up there is because we can use like common identifiers to reshape tables in different ways, but preserve those core properties. So when we're pivoting and when we are merging from wide to long or vice versa, we're never combining data. So we're never taking two observations and jamming them into the same cell. We're simply changing how we array the cells, what works as column names versus variables, and vice versa. So let me go ahead and show you what I'm talking about. There are two functions we're going to play with. Pivot wider, pivot, and I'm going to type some notes here. Pivot wider makes data with more columns, and pivot longer makes data with more rows. Fair enough. So I'm going to copy some code from the tutorial. And what this code does is it creates an object called surveys MZ. And this was surveys piped to filtering out all the NA weight values, grouping by genus and plot ID, and then summarizing the mean weight by genus and plot ID. Sure enough, if we run that copied code, we now end up with a new data frame that, or a summarized data frame, I guess we might call it, that has a column for genus, a column for plot ID, and a column for weight. And in the tutorial, we show you the genus, the unique genus values. There are 10. I have no idea what these genuses are. I guess types of rodents or something like that. And so what we are going to do is we are going to practice a pivot where we take these data, these 3-column, 100 or almost 200 row data, and make what might look more like sort of like a what you might call a crosstab in Excel that has plot ID on the columns and genus on the rows. So we're going to start with the data frame, surveys MZ, and we're going to pipe to the pivot wider function. Pivot wider because we're now going to push or cast the plot ID out over the columns or the y-axis. So we want to pivot and we're going to say names from, and that means we're taking the column names from a given variable. In this case, from the plot ID column. This is one of the cases where you put it in quotes. And then values from is the second function. And so what we need here is we have 3 columns, and now we say, hey, make a bunch of columns. So we need to say, what are the column names? And then what values are we filling in for the column names? And in this case, since the column names are from plot ID, the values are going to come from the mean weight column. And we're going to save this object as wide survey. And if we look at wide survey, or we print it off in the console, it's a little tough to print because there are a lot of plot IDs. And what we've created, though, is a wide data frame that has one row for each genus. You'll also see we've created some NA values, which is weird, right? Because we'd actually filtered out all the NA values. So what happened here is because we've said now we need a separate cell for every plot ID genus combo, what does R do if there are no observations for that particular combination of genus and plot ID? It fills an NA back in. So that's actually a clue, and I'll ask about this in class. We'll see who was here for this part of the video as to why we generally prefer, unless we have to like print it out for visualization, to store data in long format. Because in long format, we don't have to store those extra NA values. We can only store the combinations of genus and plot ID that we actually saw. Whereas when we say there has to be a separate cell for every plot ID genus combo, now we're creating the need to store NA values as well. So now let's try pivot longer. We're just going to take the wide survey and we're going to make it long again. Wide survey, going to pipe wide survey, if I can type, to pivot longer. And now we have to say, what do we want to collapse on? In this case, we want to keep the genus column as an ID value. And so the way this works is we don't want to pivot the genus column. We just want to leave it essentially as it is. So I'm going to say minus genus. And confusingly, and I get this is very confusing, genus is not in quotes. Bear with me here. It's just sort of the way it approaches it. The core reason is that you can specify multiple names to and values to variables at the same time. And so sometimes we concatenate those in a C function. Don't worry about that for now. Names to equals plot ID and values to equals mean weight. So we've actually we're calling the same thing now, right? We said names from plot ID and values from mean weight. Now we're saying, all right, send all the column names, any other column name besides genus, right? So we have 25 columns. One of those columns is genus. The other 24 are just plot IDs. So we're saying except for genus, so minus genus, every other column you see, we want to make all one column now called plot ID. And then we want the values associated with that to then be stored in a column called mean weight. So this whole matrix of plot IDs and values, take the plot IDs, put those all in one column, take the corresponding mean weights, put those in a second column next to it. Let's go ahead and view what that looks like. So we're going to save this object as surveys long. And if we view surveys long or print it off, read it off using the head function, we are back to having a genus column, a plot ID column, and a mean weight column. That is pretty cool. One thing I want to highlight is there are some defaults, and sometimes pivoting just works without specifying everything, and sometimes it doesn't. So what if we took wide survey and pivoted longer, specified the names to and the values to, but did not say, hey, don't do this with genus? We get an error because R says you have to give me at least one column that actually still stays on that we're not modifying, so we have some basis for going from one way to the other. We can't just like shake everything up and make a new matrix. So we have to preserve genus, but what if we don't specify the values to? So we're going to say keep genus as is and then names to plot ID. This one actually works. The reason is there's only one set of values, and R says, well, you told me to use these columns and you said keep genus. So I'm just going to assume that all the other value that the values in that matrix for the mean weight values are what you want the third column to be. But it doesn't know what those are called, and so it just says the third column is called value. And so those are the same values. They're just confusingly named now because R was just sort of guessing. approve it. Sure enough, if we specify values to or we don't, we see those mean weights are 7, 6, and 8.61 at the top. So one thing you can always do, this doesn't matter for this case because this is a really simple pivoting function. Pivoting can get really complicated. And so the way I actually often approach it is I specify as few things as I can and I try it and I see if the dimensions are right. I see if it looks right. And then I keep adding things and editing things until I get it right. So essentially what I'm saying is I kind of endorse a trial and error process to pivoting because I think it can be kind of tough particularly when you're just learning how to pivot and join, to write out all the code the first time in a way that works. And sometimes if you've written too much, it's tough to kind of figure out like what to subtract to get it to work. And so my preferred approach is to start with minimal input and then keep adding or editing until I get it the way I want. But I think it's impossible to sort of predict ahead of time necessarily how it will look until you've gotten really good at this. And so if you're sort of trying something and then editing from there, I think that's totally a good way to approach it in this case. And I think that'll actually help you learn how to go about it. Okay, so give that a try. Try the challenge for pivoting wider and pivoting longer as well. Feel free to refer to this script, which I'll commit and push if it's helpful. And we will talk more about this in class. Thank you.